Alright,
I'm just gonna be gonna keep along on
alright. So
the stream.
stream is live. I'm going to go into presentation mode, and we should be good. Alright.
Awesome. We are live. All right. Hey guys. Welcome to class one of Sushi Squad Design Training. Intro to Design and CAD.
Yeah. Um. Max, I switched the slide by the way.
Okay, cool. Um. So, about us. Avi, why don't you introduce yourself?
Yep. I'm a senior at Tesla STEM High School in Redmond, Washington. I'm the captain of FRC Team 7461, and I like to consume oranges.
Guys, I'm Max. I'm a junior at Redmond High School, and I'm the design lead of Team 7461. I'm a pear enthusiast.
Okay. Wait. Is the stream louder now? Asking the people in chat.
It's buffering for me a little bit. There we go.
Okay, it's loud. Got it. I think, uh, I just have to check something about the stream settings to make sure everything's working fine, then we can get started. Um, alright, so, alright, looks like we can just get going then. Starting off with mechanical design and what it is.
Right. Um, Sorry, there's like a little delay in my thing. Okay, so what is mechanical design? Um, it's engineering solutions to problems, right? It's when problems arise in the world, when you want to fix something, then mechanical engineering is something that is a solution to that. You create products to address those issues, and what that entails is planning and creating mechanisms, packaging these mechanisms that you create into a cohesive whole that can be applied to these issues, and prototyping and testing models. That's Those are the kind of the main aspects of mechanical design. And it's a really important industry skill that's not that can be applied outside of FRC.
Switch, by the way.
Yeah, I don't know. We got to find a better way to do this next time because like I can only see everything like 5 seconds after it's happening.
Yeah. Um,
Okay, so right, okay, design and FRC. So let's talk specifically about design within the boundaries of FRC. So there's a couple of core actions that take place in every FRC game, and those are manipulating, driving, shooting, and lifting. Um, and unique game objects that come with each year's game kind of allow for variety in the games, and they also require mechanical designers to design different mechanisms to perform those actions. All right, yeah, the first one, manipulating. That's like, for example, the Barker Redbacks teams, 4613. In 2019, they had a really cool intake for the large cargo balls. It was like a sideways roller belt intake that they could intake from the front, but then when they outputted the balls, it could go from the side or the front, which was really handy for scoring. And then on the left, the Spartan Robotics Team 971 in 2019, they had a suction manipulator. This was a really unique design. Um, and yes, it was really interesting. They could suction onto the cargo balls and the hatch panels to score.
yeah, so for anyone not familiar with the 2019 FRC game, the goal was to pick up these 13-inch kickballs and pick them up and score them in various parts of the field, and also pick up these these giant discs that had a hole cut out in the center. So most teams actually, for the discs, they just used some sort of clamp that clamped on the inside, but 971 just used suction for it, which was really cool. And yeah, we have some photos later on that show these types of mechanisms in action. Um,
Right. So driving. Yeah, that's going to be our the next kind of action that we look at. On the right is the drivetrain of 2910 Jack in the Bot. In 2017, they had a cool swerve drive with the 4 swerve pods there. They have a updated version of the swerve pods. Um, this is what they had in 2017. Um, and on the right, on the left, we have the team 254, the Cheesy Poofs. They had a West Coast drive, as opposed to the swerve drive that the Jack and Bot had.
Yeah, so the differences here are that the swerve drive actually allows them to go omnidirectionally, which but because each wheel can steer itself independently, which is some pretty cool engineering on their part. But as a consequence, it requires a lot of motors. So some teams will just pick up a more conventional drivetrain like this, which has 2 independently powered sides that go the same way to drive forward and different ways to turn. Um, so yeah. So, a couple of mechanisms for shooting. Um,
Oh yeah. Oh, it's shooting. So on the right, um, yeah, sorry, on the left. Sorry, I get the directions wrong.
God
The
damn it.
team 118 Robonauts in 2014. The game was aerial assist. They had to shoot these large, almost like yoga balls.
Yeah,
Um,
they are yoga balls.
okay, yeah. So then they would shoot them like pretty long distances across the field, and also score them into goals. And then so Robonauts had this really interesting and unique um, sprung ball launcher that was powered by like pneumatics pulling a coil back. And then on the right, the Citrus Circuits Team 1678, 2013. It was the game object was a frisbee, and they had to shoot the frisbee. So they had this interesting frisbee launcher using flywheels.
Yeah.
Okay. Lifting, right? So on the left here, RoboJackets Team 3538. They in 2019 we already kind of covered that year's game with the cargo and the hatch panels. But they had this really cool integrated climber and elevator. It was powered by the same gearbox, and so they could lift their intake with their elevator, and then they also use that same mechanism to climb at the end
Yeah,
and
so
score points that way.
yeah, so at the end of the match you had to climb onto this blue step right here. And so what they did was they actually combined part of their intake with their main elevator lifting mechanism that lifted their intake up and down, and these forks at the back, which all kind of just came together to lift them up onto the platform. And another cool lifting mechanism is Team 33, the Killer Bees, in 2018, where they actually did this really cool double reverse 4-bar linkage to actually lift. The game that year was to pick up yellow cubes and put them on a seesaw type thing. And what they did was they actually had this really cool array of beams and pivots to do it. So, strategic design. So, we've covered some of the mechanisms, but a robot's only as good as the role it's able to play. So, for example, in the 2020 game, there's a game piece known as the Wheel of Fortune. I mean, the control panel. We called it the Wheel of Fortune because it looked like one. But there was an element of the game that at pretty much every level except the very high levels, it was basically completely useless. And the idea was you spun the Wheel of Fortune and it got you a couple of points after you met a couple of pre-existing conditions. But when you actually looked at what its impact was on the game, as well as how many teams actually met those conditions, and also just the time to score. You saw that it was a relatively minor part of the game that didn't really accomplish anything. And so teams who spent their time doing that could have spent that time refining another mechanism, especially early on in the season when teams weren't meeting those preconditions. And it's better to do a few things well than many things poorly. So, for example, my first year in FRC, the team I was on, we built a robot that tried to do everything, tried to lift. It was 2018, so we tried to lift onto the scale, which was this big seesaw thing, and we tried to climb, we tried to do everything, but our team also didn't even know CAD existed, or we knew it existed, we just chose not to use it. And so, because of that, we ended up scoring, I think it was a grand total of 1 cube on the scale all season. And the rest of our time was pretty much just spent not really being a useful robot. So, yeah, it's better to do whereas, for example, an example of a team that did a few things but achieved extreme levels of success would be a team literally 5 minutes walk away, Team 2976, where they only focused on the lower goal, but because they were so good at it, they ended up making it to the World Championships, and they got picked by two amazing teams to complement their alliance, and they ended up winning the World Championship that way. So that's just an example of teams with similar resources, sort of one team going in a direction of trying to do everything and not doing it well, whereas the other specializing on one aspect of the game and doing it really, really well. And so strategy is, if you have a very defined strategy, you can make some key trade-offs and design decisions that really can amplify your play. So for example, in 2019, Team 2910 Jack and the Bot, here you can see they're scoring these orange balls. They only scored them into the lower goals. They did not touch any of the higher goals on the field, because in 2019, if you did game analysis, you could see that they were all worth the same number of points. So by doing all of these really fast, they arguably were one of the highest scoring robots in the world. And they were able to devote more resources to their climb and just more resources to iterating the robot, so that, quite frankly, they just destroyed the heck out of the Pacific Northwest. And, oh yeah, I've got a notification for updating Chrome. Fun. So yeah, that's one of those key trade-offs that you can see teams making that can really sort of influence, I guess, how they play the season. And just because if they didn't do any strategic analysis and just looked at the game and went, okay, we're going to do the high goal, and then started designing day one, they wouldn't have ever been able to make that trade-off that allowed them to achieve such high levels of success. And similarly, this also enables key design decisions. So, for example, in 2018, I mentioned how you had to put the cubes on the giant seesaw. And so what Team 2471 did was they actually, they designed their entire robot around having as many points scored in the autonomous period of the match. So what they did was they actually had this lift system, but they also had this arm that was able to reach around backwards, and instead of just having a simple wrist that could only reach like the minimum amount to hold the mechanism inside of your frame perimeter. So what that enabled them to do was reach over the back of their robot, and during auto, that actually gave them a huge advantage, and they were one of 2 teams to consistently hit 4 cube autos. Actually 3 teams to consistently hit 4 cubes in autonomous in 2018. And so, knowing all this, what every team should do is make a priority list at the beginning of the season. So, I guess what sets a lot of really good teams apart isn't that they don't try to do everything, as much as they know when to take things that are lower priority and just cut them from the robot. So, for example, our priority list in 2020 was climb every match, which we had some issues at competition that prevented us from doing, shoot in the high goal, and then I think I think it was hold 5 balls, intake from the floor every match, um, manipulate the Wheel of Fortune, be able to adjust on the climb bar to have space for partners, etc. But because we didn't have enough time, we actually cut a few of those features from the bottom, which enabled us to actually, I guess, a priority list is a really useful tool for figuring out where to focus your energy and um, where to actually cut stuff from your robot. So when it's week 4 of build season and you're behind, what features of the robot do you cut such that you can get a robot done in time? And that's sort of, I guess, the big thing is you've got to, especially if you're not a team with the resources of, say, 254 or 148, you don't have the ability to do everything. So what you want to do is make that priority list and just cut stuff from the bottom as you realize it's not possible. So, or shelf it for later. So, for example, we had a mechanism for the Wheel of Fortune in the works for the Pacific Northwest District Championship, but we didn't have it at our first event and wouldn't have had it at our second event just because it wasn't really that high of a priority until later in the season. And so there are a couple of golden rules regarding strategic design. So number 1 is always keep it simple. So build within your team's capabilities and just build as simple of a mechanism as possible, because simple means it's solid, so it's going to be more robust if it's got less moving parts. And so, for example, I guess in 2018, Team 971 did this really complicated 2-jointed arm to pick the cubes up and put them on the seesaw, whereas and they have the resources to do that. They've got really talented students, really experienced mentors. They've got really fast machining, so they can do that. But for a team like, say, for a team like, say, I don't have an example off the top of my head, so I'm just going to go with Team 5499 in 2019. So, which is a different game, but you still had that lifting element. So what they did for their lift was literally take a kit somebody had put out and was selling for making I guess, consistent linear motion. I believe they used the Gray T kit for that. And because they used that off-the-shelf mechanism that was a lot simpler than this crazy custom-designed 2-jointed arm, they were able to spend a lot of time refining the rest of their robot. And so, I guess, and it was also a lot more reliable than them doing some sort of crazy 2-jointed arm would have been, just because they didn't have the resources to make the other one work. So, I guess it's a matter of, also, for example, I guess a good example.
I think a good example of that is like kind of is us in 2019, right? And also the 2019 off season, where our in-season robot had an arm. We had our rookie year, we made an arm for a robot, and we didn't have any experience with that, so it went wrong in so many places. But then in our off season, we kept it simple, and we just had a pneumatically actuated like linear slider for hatch panels, and then we scored we did so much better, and we scored like so much more than what we did in season.
Yeah, so that's actually a really good example of that I should have thought of. But so again, our robot in the off season did not have the ability to pick up balls from the ground. It did not have the ability to score them in one of the goals, but because we made it a lot more simple and kept the number of moving parts so minimal, we were able to do a lot better just because of the fact that it was a lot more reliable. So we weren't constantly going between matches and trying to fix the fact that our robot had entirely fallen apart. And golden rule number 2 is that if your team has 30 units of robot, it's better to have 3 functions at 10 out of 10 instead of 5 at 6 out of 10. So, for example, Team 1257 in 2016, So the goal in this game was to shoot these gray balls into. Wait, here, let me see. Okay, that might be a bit cut off, so I'm gonna move the video for a second. But the goal was to shoot these gray balls into a high goal or place them in a low goal, and also climb at the end of the match. And what they did, since their team was really low resource, so what they did was, instead of spending a time designing a robot that would do all of those at like 6 out of 10 or 4 out of 10, what they did was they just focused on driving, crossing the defenses, which were these obstacles on the field that you had to cross for points, and putting the ball in the low goal. And that year they won 2 events and made it to the World Championships with this extremely simple robot. So, I guess it's always going to be better to do a few things well than a lot of things poorly. And part of this is also eliminating effort where possible. So you can get away with sort of outsourcing units of robot in a sense, where, for example, if you use the kit of parts chassis, which is this drivetrain that you get in the kit of parts, then you don't have to spend any of your units of robot working on a drivetrain. Similarly, you can use an off-the-shelf lift kit, as I mentioned, and then suddenly now you still have 30 units of robot, but you have 30 units of robot to put in, but because you're using off-the-shelf parts and off-the-shelf mechanisms and sort of outsourcing that work, you're able to get to a robot that has 45 units of robot put into it, even though you only had 30 units to give. And I guess this metaphor sort of breaks down there, because at that point it's just not worth extending. But the idea is you can eliminate effort and also cut unnecessary functions. So for example, in this game, 2020, where you had to shoot balls, you could cut, for example, shooting from anywhere on the field. And that made your shooting mechanism a lot simpler, because you didn't need a turret, you didn't need the ability to adjust your shot angle. And so, while you're still scoring similar number of points, because of the fact that one ball going in the high goal is the same regardless of where you score from. And finally, the third golden rule is steal from the best, invent the rest. So what this means is, you're not supposed to reinvent the wheel. How many times have you heard that saying? It holds doubly true in FRC, where chances are, if a challenge exists in a game, something similar has been done in a prior game. And sure, there are always new. Oh, and I'll move the video back. But there are always, like, obviously new challenges. But for example, this story is used a lot. But Team 1678, they're arguably one of the best teams in the world. And what they did in 2011, which was their first year they won an event, was 2011 you had to pick up these inner tube things that were sort of rings, and one of their mentors, who was a student in 2007, noticed that the dimensions were almost identical to the inner tubes that they used in 2007, which was a very similar game. And so what they did was, he remembered a robot that he had seen in 2007 that had a really good manipulator. They projected it onto a whiteboard. They projected a picture of that robot's claw that had that really good manipulation ability, sketched it, like traced it onto a sheet of metal, jigsawed it out, and that was their manipulator. So they didn't actually have to do any innovation work there. Instead, they just took it and rolled with it because it already worked. And admittedly, that's a really extreme example, but in this year, for example, you could take climbing mechanisms from 2016, 2018, and 2019, sort of, and I know teams who took climb mechanisms from each of those years, and that saved them a lot of time versus trying to think of ideas and just completely redesign. And similarly, there are also teams that make all of their resources public. So this is the Open Alliance. There are a couple of teams who essentially just have build blogs, and they make everything from their season public. Prototyping numbers, how their prototypes worked, everything. So what you can do is let them do the prototyping for you in a lot of ways. So for example, we I don't have a picture of this, but there's this shooter that some people over at West Coast Products develop. It's called the Gray Tea Shooter, and it's essentially them prototyping a shooter and then selling it as a kit. And so what we did for our shooter this year, even though it was a very different mechanism, was I literally traced a sketch. Well, not. I created a CAD sketch over the outline of the plate, and I just reworked that so it fit our geometry constraints. So we had a different entry and exit angle than their shooter, but I straight up just copied the rest of the geometry there, and that saved us a good week of prototyping on shooter. So you can let other people who are more qualified than you do the work for you. So I guess this is sort of stealing brain power in a way, where you're just letting them do the work so that you can focus on other things. So we focused a lot on our intake and hopper this year. And golden rule number 4, use a proven drivetrain. I can't say this enough, but your drivetrain cannot win you a match, but it will lose you a match for sure. So like there's the kit of parts chassis for any rookie and less experienced teams. I'd recommend the kit of parts chassis, but for veteran teams who have experience building other types of drivetrains, just stick with what you know. Um, you absolutely do not want to be innovating on your drivetrain in season. That's the biggest thing. So this like your drivetrain is not going to be the limiting factor in 99% of cases. And if it is the limiting factor, you're not watching this video series. So um, you should, instead of that, spend your time iterating and refining those mechanisms. Like, for example, again, my rookie year, the team I was on built this really janky custom drivetrain that, I mean, it worked, but it took 6 people who could have been helping with other parts of the robot, and it still had a bunch of issues and caused issues at competition. And so, I guess what I'm trying to say is you should, I guess, prioritize what you need to work on, because your mechanisms come first, then just iterating those mechanisms, then comes practicing, and at the very, very end of it all, it's improving your drivetrain. Because, yeah, it's just not something that's really worth iterating on. And, yeah. So, finally, you always want to have continuous intakes, also known as rolly grabbers. So, instead of a simple claw, you might, to pick up balls, like this is a 2016 robot, instead of having a claw to pick up the balls, they just had a set of rollers that directed the ball into the center and pulled it into the robot. And what that actually enabled them to do was have a much higher range of acquisition, and it's much faster because you don't have to like grab the ball, pick it up, drop it inside the robot. Instead, you just have this continuous roller path. And that just makes picking these up a lot easier. And that's pretty much it as far as strategic design goes for the scope of this presentation. Citrus Circus has put out a much more comprehensive workshop on this that y'all can take a look at. And yeah. So, an introduction to CAD.
So some of you guys might be wondering, like, what is CAD? Well, CAD is it's a tool that the mechanical designers use, and so like what CAD does is it allows us to model complex parts a lot more easily. If you look at like a traditional mechanical designer's job, they have a lot of blueprints. They make a lot of like physical drawings, and that's really great. Another great tool, but it's not as easy or as dynamic as CAD. Which I should define what CAD is. CAD is computer aided design. That's what the CAD acronym stands for. And so back to how it's used to design parts. Um, it's a lot more it's a lot better for collaboration. It's a lot better for editing than physical drawing, and so that helps it um be easier to use. And so the way you use CAD is that you lay down geometry with sketches, and then you manipulate those sketches through the tools that are built in with the CAD software. Yeah, so another aspect of CAD is that it's like a planning tool. It helps you visualize how parts fit together, and then also visualize how those parts, how the mechanisms that the parts make integrate with one another. Yeah, and then kind of the last, uh, slightly less important aspect of CAD is it helps you document the prototyping process. We use it all the time in season for all sorts of things, and it helps us kind of see where we've come from and like all the pitfalls we've hit on the way from our initial prototype to our competition product. And so, yeah, this is also a tool that's used extensively outside of FRC. So if you learn it for FRC, it's going to be really useful if you ever want to become a mechanical designer as a career option. Okay. All right. So just a couple of quick CAD examples from our off-season bot. This is part of the shooter that actually Oppie designed. Um, this is like the gearbox mounting plate for the adjustable hood. And if you see right here on the left of the screen, this is the drawing. This is the sketch that the initial sketch of this particular plate. You see all the dimensions, everything's constrained. Then on the right, the pink plate on top, that's the extruded part derived from the sketch you see on the left. And so you see all the matching kind of components that were detailed in the sketch being like brought to life in like when it's being created into a physical part of the sketch. Okay, and then this last drawing is just to kind of show you how CAD can be used to demonstrate can be used to plan like the integration between different mechanisms. Like obviously, like the shooter, it's a separate mechanism from the hopper and the intake, but in the beginning, we kind of plan all those mechanisms to get like mechanisms out and how they will fit together eventually, which helps with making sure there aren't any issues later on. If you see like the main layout is in the background and the hopper is in context with that layout, so it's really easy to see if there's any clearance issues or if one thing will intersect with another. And so yeah, that's kind of how CAD can be used as a planning tool.
Alright, so we're going to be doing a bit of a demonstration for modeling and sort of just, I guess, how CAD can be, like, sort of what our workflow is. So, yeah, I'm going to quickly just open Onshape. I'm just going to quickly open Onshape. And yeah, we'll just get started on that. So, I'll just create a document. So, I guess one of the good things about CAD is that you can lay everything out in a sketch, and sort of just, I guess, here. For example, let's just say I wanted to make a simple. Actually, not sure what I should make. Suggestions in Twitch chat, please. Yeah, if anyone has suggestions.
I'm waiting for David's dippy swerve.
Oh God. Yeah. All right, but I guess one example might be, obviously there's not really a lot I can do in a short period of time, but I'm just gonna do a simple frame. So I'm just gonna make like a simple rectangular frame. And also, one of the other reasons CAD is super useful is because you can catch a bunch of clearance issues in CAD that then, so what I just did there was I made a sketch of the two-dimensional view of the frame. It's just a 90-degree angle. Shoot, that added those together when they're supposed to be separate parts. But, especially in FRC, when you've got such tight timelines, like you've only got a month to build the robot effectively. And so what you should really be doing in that time is not, like, you don't want to build a really cool climb linkage and put it all together only to find that, say, the gearbox doesn't work because of an unforeseen issue. Um, or, like, that's just one example of, but the point is that that type of thing can set you back 3 or 4 days in build season, which is obviously a huge, not to mention cost, which is obviously a huge issue when you're working on that type of time frame. So the benefit of CAD is that you can catch those issues before you actually build. Well, that's at least one of the benefits. So then I'm going to use this feature script, which essentially converts all of these to box tubing for me. And I can finally just sketch out. And so, by the way, what I did there was I modeled these as the type of extrusion we use, which is essentially this rectangular profile extruded outwards. And then what we do after that is in our shop we'll actually we'll have a sponsor do this, but just drill holes at regular intervals, which provides like a standardized grid in case we need to adapt something really quickly. So I mentioned how you don't want to be losing a lot of time in build season. So one way you can do that is make sure like that all of your, I guess, stuff is built around this sort of adjustable box tubing model where it's all really robust. But if you need to change a length or something, you can just cut the existing tube down to size instead of remaking and remachining the entire thing. And that can save a lot of time. So I'm just going to convert these entities in Sketch. And part of the homework is going to be actually learning how to do this so that for the next lesson there can be more complicated homework since the next one is actually on all the different construction styles in FRC. So by then we're expecting everyone to have a basic understanding of CAD so that once they're, I guess, once that's done, all said and done, you'll actually be able to model these sort of complicated mechanisms. So I like to do my outline on my brackets 0.75 inches offset from each hole, which gives us a lot of material but still saves a bit of weight in the corners. Set that tangent there. So that's a very basic demonstration, but I hope that sort of gives some of you insight onto how our workflow goes, because we do, like, here, I'm going to go back into one of our other documents. So, let's see, 2021,
Avi,
yeah,
Avi.
yes.
Where's the fasteners, bro?
Oh, didn't feel like modeling them
The
this time.
fasteners, bro.
Max, we only model fasteners for, actually,
Okay.
for that one, all of those fasteners would be rivets, and you don't
let's see how it
really...
is.
There are no clearance issues which you need to model fasteners for, but I can show you fasteners. Alright, so this is our off-season. Actually, that's the wrong document. We actually do two separate documents, but I guess we do two separate documents, one for our main assembly and one for everything else, because that way having a separate document means that it's only checking. So what it does is it loads I guess it sort of caches a version of each mechanism from here into that document and then doesn't update them to the latest version until you manually tell it to, which means that when loading, it's not going to constantly check for any small updates to any of the parts, meaning your your main robot model is actually going to load a lot faster if it's a separate document that has everything, how do I put this? That has everything, I guess, modeled as one main assembly, and then have all of your sub-assemblies in one document. Um, because then that way it's not constantly checking.
We got a question in the chat. That person's asking that you can go back and do that more detailed. I'm assuming they're talking about the frame.
Oh.
Correct.
Okay. Go back and yeah, I'll do that in a second. So here I'm just gonna finish showing off like sort of more complex mechanisms. So this is the assembly. I do have some fasteners detailed here, though admittedly I need more. But for example, that's the shoulder bolt that slides in the slot. But alright, so yeah, I'll just go back to that real quick. So I guess right here, this assembly is this part studio is just an example of how we do everything in context to each other. So if I show all, which is, as you can see, pretty much everything is modeled here. We've got our balls, the sort of path they follow entering the hopper. We've got an older version of our hopper, top down and side layout. We've got our intake here, which sort of just shows the path the balls will take. And then finally we've got our ball sort of modeled here relative to the bottom roller of the hopper, and this kicker wheel that goes on this shaft that pulls the ball up and into the shooter. And so what that does is it actually enables us to, I guess, know that by the end of the hopper, the ball, once we can model where the ball is at the end of the hopper, and from there find the optimal place to put the kicker wheel. And then the path it follows as it goes up through the shooter, and just, yeah, everything's sort of modeled in the sketch. Then, I guess when then you've got more sketches, and then from that really detailed sketch, then you extrude up your parts. So not a lot of work is done in 3D. Like, I'd say most of the time spent in CAD is going to be doing 2D modeling, with, I guess, everything sort of coming together in 3D, but really you're planning out your stuff in 2 dimensions, and occasionally switching to two dimensions from another frame of reference. So I might do a front layout sketch if I really need it, but what that allows you to do is, again, just plan stuff out.
Wait, I'll be just real quick. We got another question.
Yeah, I saw it.
Okay, cool.
So how do you project the geometry of the side profile of the drive base? So here I'll just so what we do, and admittedly we found better methods, and I'll be covering those in a future thing. This is a pretty old layout sketch, a couple months old, but the method I like to do now is actually just derive the parts into my part studio and then build everything up around those derived parts. But what I used to do was create a part studio in context, make a sketch on the face of the drive rail, and then just use the convert entities feature to actually project all of these. So I just literally convert entities and then click on the faces of the, like I'd click on this face right here, which just projected the entire thing. Obviously there are better methods to do it, so I don't recommend doing this because in context part studios have a lot of issues and can break occasionally. So they were the best option for a time, but we've since found better ways to do it.
It's much easier to like derive the part studio and then use that as the reference in another part studio.
Yeah, okay, so for the modeling demo, going back to the sketch, so what I did was here, I'll just add another rectangle for the sake of convenience, is what I did was I actually created this sort of rectangle thing, and then when you actually finish, you can then drag the mouse over, and as you'll see, there's a highlight around this dimension. It gets boxed in, and so then when I type in, for example, 2 inches, this entire thing, it automatically sets that dimension. And similarly, if I hover over this dimension, I can then say 10. And what it does is it creates this 10-inch long thing. And so that's sort of just a much faster way of doing rectangles, and it's just a lot easier. Does that answer your question? How did you make it 3D? That's a great question. So this is going to be covering the Onshape pathways that we're having for homework. But what you do is essentially you just click on this, and you just click on this using the extrude feature, and then it makes this, and then there's a feature script, which is a script somebody wrote that you sort of program. Well, a feature script is essentially a programmed CAD tool that sort of just automates parts of CAD. But the manual way to do this would be to use the shell feature, which hollows out a face. Let's see, hide that. I'm just going to hide that part real quick. Shell feature to hollow out the center, and then you do a sketch here where you'd have like your hole, and then you'd extrude that and then pattern it down the length. But yeah, the feature script's way faster. I recommend doing it manually for the first couple of times, mostly as character building, but also because it gets you a feel for the mechanics of how CAD tools work. So when you're designing more complicated parts that can't be automated, you've got that sort of intuitive feel for how the tools work so that you're able to model those parts effectively. And I can see Max. I can see Max is laughing. Yeah, suffering does make you strong. Um, it is character building. Anyways, so yeah, so for the homework. So the homework is going to be complete the Onshape Fundamentals CAD pathway. So for this next week, so I'm just going to go in. So inside Onshape, you've got this learning center here, and let's see, this learning center, it's a great, I guess, they've got a lot of self-paced, so inside self-paced courses, they have Onshape learning pathways, and there's this, if you click on all of them, you've got this Onshape Fundamentals CAD pathway that goes over the basics of modeling in Onshape, and it's going to be really good for everyone if they finish that by next week, just because it sort of condenses all the information you'll need to know. So you could pick up the software otherwise, but it would take a lot longer and you'd be a lot worse at using the software. No. Okay, so somebody asked in the chat, does this cost money? So Onshape is free for students. So here, I'm just going to go into an incognito tab real quick to demonstrate. Here. Google Onshape. If you Google Onshape for students, you can go to this site, and it basically allows you to have free Onshape. And for mentors, what you can do is actually instead of putting down student, you can just put down educator. It doesn't really matter if you're technically a teacher or not. They've said that they're fine with any mentors using Onshape using this plan. So Yeah, Onshape's all FRC CAD is free. So well, pretty much every company has free ways to get their hands on CAD software. And PTC, the company that makes Onshape, they're amazing folks. They've got a lot of resources and um, they're just really cool people. So, yeah. So, back to the homework. So, another thing is going to be once you're done with that, start researching robots. Just look at literally just Google FRC and watch robots, see how they do things. And a bonus task, if you're extra and have time, is going to be to try to CAD a basic mechanism. So, just like a simple roller or something. Doesn't need to be too detailed. We're going to cover a lot more about CAD in future lessons. So, but yeah. Um, also, helpful resources if you're looking for robots. Chief Delphi is a good place to see old robot photos. The FRC Discord as well. Just any of those places are useful.
So if you go on YouTube and search up FRC over the bumpers, sorry, behind the bumpers, sorry, they
Max
have a
has
bunch of
PTSD
really
from our
awesome
intake.
videos. True. Yeah, the behind the bumpers has a lot of great videos. They kind of just summarize all the main components of a lot of really awesome and stellar robots.
Yeah, so
Feel free to check those out as well.
somebody asked when the homework's supposed to be due. So while we're not going to be expressly checking the homework for, well, we're checking it for kids who are on Team 7461, for off Team 7461. You can submit your homework to us and we'll look at it, especially as the future goes on. But there's obviously we don't have the ability to like mandate you to do anything, though we will be extremely disappointed if you don't. So, but the homework's always just, in general, it's preparation for the next lesson. Because the idea with this series is to actually condense a lot of knowledge into a short period of time without the sort of hands-on mentorship that a lot of teams have. So for people, like, I know a lot of teams don't have, like, the CAD mentors or anything who can sort of distill that information. So because of that, we've got, the homework's going to be pretty involved, and it's going to sort of supplement the lectures. And the idea is we start every lesson assuming you've finished the homework from the prior lesson, just because then we are able to sort of build off that material. So, yeah.
Right, and also feel free to like post the homework. I'll make a homework channel in the Discord, and then I guess we'll have some people look at it whenever they have time and try to give you as much feedback as possible.
Yeah, any other questions?
It's hard to believe that Mint Mobile has gone so long without an unlimited.
Oh shoot, I'm trying to play music in the background and they've got the ad, so. But yeah.
Right, so someone in the chat asked how we get the feature script for the holes. We'll send out a link to all the useful feature scripts. Some really cool ones that we use in the Discord. Maybe.
Yeah.
So that'll be probably a good
we're gonna
place
be
to put those.
Yeah, we're gonna be covering feature script usage and all of the feature scripts we find useful in a future lesson. But for right now, we're not gonna be messing with those much. Just because the goal is also to get people familiar with the basics of modeling, so that by the time they're able to use those advanced tools and save themselves a lot of time, they have that understanding of how each tool intuitively works. But yeah, again, all of the fundamentals pathway sort of covers this in much greater detail. So.
Right. If there aren't any other questions, then
Yeah.
I think that's probably the end of our very first design training session.
Yeah. So.
Well, thanks a lot for attending, guys.
Yeah, thank you so much for coming out
Howdy,
and
go ahead.
putting up with all of the technical difficulties. We're going to, if you have any questions or anything, feel free to contact us. And I guess we're active on Discord and on Chief Delphi if you're not on the Discord server. And if you, I guess, have any questions, just feel free to shoot us a message and we'll be free to respond. Thank you all for coming out. Peace and love. Yeah, no problem. It's two. Okay.
Peace and love.
Yeah. So yeah. Again, just shoot us a message and we'll be there.